Hi guys, welcome to my channel. Today let's solve yet other lead code question. The description of the question is as follows that we were having a strange printer and the printer can only print a sequence of same character each time. At each turn, the printer can print new characters starting from and ending it at any place and will cover the original existing characters as well. So the description of the question is quite simple. I'll just write it as note points. Sequence of same characters is printed in each iteration or in each step. This is the first step of it. And the second point being from start to the end, the printer can be going to and fro and it can even replace the existing characters with the sequence of any current character. So let's just consider the first example of it, where S is A B B B. In this example, you could see in my, I would say that in my first iteration for the printer, I'll just specify to print three A's as a sequence, and first step is done. And I couldn't say in the first step only print three V's only, so because as my first step suggests that it prints only the sequence of same characters. So in the next step, I'll just specify that after 3 years, print 3 V's, and then the second step is also done. So I'll just specify my printer that followed by 3 years, print 3 V's. So that's done of it. Let's just consider the second example. If I just consider the second example, I could ideally say my printer to print A in one step, followed by A, print B. That's again one step, followed by B again A follow that's again one step. But this would add up to 3 steps. I'll just specify first A B A is there, so print 3 A's at the very beginning and replace this A with B. So that would need only 2 steps. So 2 steps are lesser than 3, and my printer need to choose ideally the most optimal solution. So ideally the most optimal solution would be 2 only. So we'll finally return the answer 2 itself. So how would I do this problem? The idea in here is really very simple. I'll just specify that if my string is A, B, 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 C, C, D, E, F. I'm just calling this. You knew that this is a kind of recursive problem because I'm just specifying that I knew for printing these A's I do require one step. So I'll just add this one step to my answer, and for the remaining part I'll just call a helper function or whatever you would call like it to call, and followed by this string. This string is again a newer problem to my printer because it's not aware of what it printed earlier, but we already added that to our operations, and printer is again considers this as a new string. So this is kind of recursive problem. And being a recursive problem, I'll also like to say you the other thing. So if there are 10 A's followed by 10 B's, then there won't be any matter if there are 2 A's, 3 A's which are combined together, because ideally my printer would be considering every ideal character as the same and it could print sequence of the same characters, right? So instead of keeping these A's count, I'll just replace it with by A. For A, if I need only one print operation required, then for 10 A's also I do need only one, which are consecutive only one operation required. So I'll just specify, I'll just string call remove consecutive characters, string yes, I'll just call size to be s dot size, string result to be empty. So I'll just specify for int I equal to 0, I less than size, I plus plus, if I equal to 0, rest plus equals to s of I. If it's not equal to 0, I'll just specify else if s of I is equals to s of I minus 1, continue, or else I'll just specify else if, okay, this should be continuing because I do not need to add that, else I'll just specify, I'll add my SI to the result. I'll simply return result over here. I'll just check if cout is less than what I call the function. No conjugative characters. S less than handle, and for debugging purpose I'm just returning -1. So I got AB, and that's expected because I'm just remembering my conjugative characters. And after this, I already told you that we need to find out dynamic programming or recursive calls approach. So for recursive calls, what I'm specifying you is, see, the idea in here is really very simple. So if my characters that to be printed are this ABCD and ABCD. So what I'll do is, from the very start is 0 index and end is n minus 1, because we are just specifying it's a 0 based index array. So start will always be 0, end will always be 9, n minus 1. So what I'll specify over here is, I already knew the maximum number of operations that are required are, I'll just consider this one character. So ideally, what for maximum number of operations, what I'll do is, I'll just print this 1j and followed by helper of B, C, D, A, B, C, D, and followed by that I'll just specify 1 plus helper of C, D, A, B, C, D. So this is my worst case condition where I'll print each character separately, and then for the helper function I'll just give the remaining string. But for considering the best case, what I'll do is, from this index till the end index, I'll just check if my current character is equivalent to this character. I mean, any character in between. So in that case, what I'll do is, if this is the case, then I'll specify that I'll just print all the A's till here BCD, but all A's should not be ideally the case. So I'll just here one operation is already performed. I'll just call helper of BCD again. So helper of BCD will take 3 operations for suppose, and this is only this. In that case, my total number of operations would be 4 only. So, ideally, what I'm specifying is, if I found the start character and end character to be the same, or this character and this character to be same, I'll just specify. Now you just compute the sub problem for this, and followed by the substring to the later part of it if there's any. So got my point. I'll just write it over here. Int helper string s int start int n. So ideally, if my start is greater than n, I'll just return 0 because there's no part remaining over here. And min operations would be here. 1 plus helper of, I'll just specify start plus 1, and n would be the same because I'll just process the next character of it. And here for int k equal to start plus 1, k is less than or equal to n till the end, k plus plus. I'm just checking if my s of k is equals to s of start. If my s of k equal to s of start, then what I'll do is, my min ops will be min operations that are need to be performed, and helper of, yes. Now for the first part of it, my start, what my start would be becoming. So start would be from start plus 1, or I just consider it as k. uh, so this would be start k minus 1 plus helper of s k plus 1 and end. So this is how it should work ideally. I'll just return minimum operations from here. Return helper of, I'll just also as modified to be size to be as modified dot size. Here in the helper, I'll just return as modified followed by 0 followed by size minus 1. I'll just try running this out. So yes, it's working fine. You got the intuition what we are trying to do over here, right? So if my stat is greater than n, then obviously there's no substring part remaining. So I'll just return 0 in the case that I'm specifying my printer. There's no character remaining, so you do not need to perform any operations. And min-mem operations initially is initialized with maximum value, and maximum value here is I'm just printing the current character and then giving my helper function all the remaining part of the string, specifying the start point to be the next index other than the printed one currently. And here I'm just given this as an example, or else I'll just consider the example as B, A, C, C, oh sorry, C, D, E, F, A, X, Y, Z. So here, for example, just consider this example where my start is at this position and end is Z. Or I'll just remove this. So start is A, end is Z. So I'm just checking for my start for plus 1, that's from here till the end character if my s of start is equivalent to that character. So you could check that my s of k, I'll also write indexes for your better understanding. So that's A, C, D, E, F, A, X, Y, Z. So if I just return my indexes, it would be 3, 4, 5, 6, 7, 8. So you could ideally see that my start plus 1, that would be 5. S of 5 would be equal to S of 0. In that case, what I'll do is minimum operations of S of start would be 0 only, and start position would be same, and end position would be k minus 1 because this is already considered. So I'm just specifying that until the previous character, or else I'll just write it. Sorry for wait. I'm just specifying that this character is already considered, so I just need to process everything from this point to this point. Why everything from this point to this point? Why not remove this a as well? Because here we are not adding any one, right? So we are adding one at the very end. So I'm just specifying the adding this a, so that this a won't be considered, but this a will be added at the very end position where start would be greater than this condition would be executed. And similarly, from k plus 1 to end. So this already been processed. So I'll also specify from x to z also process it again. Why I'm not removing this a, that's quite clear, right? Because we are adding all the substrings, and I also need to add character a at the very end, or I need to add one operation for character a as well. That's why I'm just starting from the start again. And this is how it works. So you knew that there would be many sub problems that's repeating, and the best I'll show you for that would be the editorials one only, where I guess they gave some. They might have given. So if you consider this lead code as an example, the possible ways for the split are LEET obvious, LET CODE, and you could see CODE are repeating in both the cases. So to remove this kind of disparity, or remove this kind of where states are computing multiple times, what I'll do is I'll just specify my vector in dp to be, uh, I'll just call it down because size is initialized at the below. So I'll just call dp to be size plus 1 and vector in size plus 1 followed by minus 1. This would be dp, and this should be vector int dp. So I'll just check if my dp of start and end is present or is already computed. Then I'll just specify dp or return the subproblem state that's already stored. Else I'll just specify my start and end subproblem state would be the min operations. And I also need to pass my dp in this helper functions as well, because that's passed as an argument. Obviously state will be need to be maintained and will need to be passed. Here as well we need to pass the dp, and it's working fine. I'll just submit this out. So it's working fine. For fairly reducing the time taken, I'll specify my C++ compiler not to import any libraries from C that will be useful for taking input or giving output anything. So I'll just specify my cin.i should be null, because I do not need to take input anything from the compiler, nor I need to give any output to the terminal of it. I'll just submit this out, and this is how it works. So feel free to add anything in the comment section if you think anything is unclear. Thank you.